All right, welcome to Unit 8, Lesson 2. We're going to continue to solve equations by factoring polynomials. The first thing I want to do is finish where I left off on Lesson 1. I know that we didn't quite get to the last slide there, so I want to go through that one quickly. If you remember correctly from the first lesson, we were trying to solve equations for a variable x or some other variable by factoring. And we did that successfully with some other ones. You remember, we took out a greatest common factor, we factored it as normal, and we set each factor equal to 0 using the zero product property. And that's what lesson 1 was all about. And now, at the very end of the lesson, we talked about this example, how to write a quadratic in standard form that has the following solutions: x equals 4 and x equals 5. Well, if we know x equals 4 and x equals 5, and that solves the equation, we know that the factors that led us to those answers, if I were to just subtract 4 and subtract 5 over, I would get x minus 4 equals 0, and I would get x minus 5 equals 0. So if that was the case, those are the two factors that would have led to my answers of 4 and 5. That means if I were to multiply those back together, remember, because before we were factoring, or basically separating into a product of two different binomials. So now what we're going to do is multiply them back out to get what the quadratic was to start with. You can think of this as moving backwards. What I'm doing now is distributing using the FOIL method. So actually I'm multiplying binomials, first times first, outer times outer, I get negative 5x. I get inner times inner, which is going to be that negative 4x. And finally the last times the last, which gets me positive 20. Okay, that should be familiar to you from the last unit, Unit 7. And so therefore, when I combine my like terms, I'm going to get x squared. Negative 5x's minus 4 more is minus 9x. And then plus 20 is what the original quadratic equation would have been, set equal to 0. Now you really only need this part to the left of the equal sign, because that was what the quadratic expression was, but we would have had to set that equal to 0 to get the answers of x equals 4 and x equals 5. Let's look at the next example now. For b, x equals negative 3 and x equals 1 are the solutions. Remember, a solution is a value of a variable that makes the equation true. So we know that negative 3 and positive 1 are solutions. That means that if I were to just solve, or kind of go backwards from solving, just go in reverse, I'm just going to move things over. X plus 3 would have had to equal 0, or x minus 1 would have had to equal 0. So I'm going to use those two linear binomial expressions to write two factors here, x plus 3 and x minus 1. And those would have had to been set equal to 0 in order to get the process going. So I'm going to multiply out, and I'm not going to show all my steps for this one then. Positive 3 minus 1 is going to be a plus 2x minus 3 equals 0. So the quadratic expression I would have started with is x squared plus 2x minus 3. All right, great. So that was just finishing lesson 1. Let's move on to lesson 2, which is essentially more of the same. We're going to continue to practice solving quadratic equations or other polynomial equations by factoring. So remember our factoring algorithm. Our equation that we started with is this first expression. 2x squared minus 9x minus 35 would have been the equation I started with. What I'm going to do is go through my factoring algorithm, which step 1 is to look for a greatest common factor. Do I have anything that I can divide every term by? And if I do, I want to pick the greatest one. 2, 9, and 35 don't have any common factors. And then x squared, there's no other x's in 35, the negative 35 there, so there's no greatest common factor. I check for special cases in the first term and the last term, so that's not a special case. We're going to move on and just try to do the guess and check method of factoring. If you use factoring by grouping, you can use that method also, or you can use the AC method that I started to teach you. But I think guessing and checking is mostly what people will do, so I'm going to guess and check. What's nice about this expression is that the first term, 2x squared, is prime. That means that there's only one possibility to multiply to get 2x squared, and that's 2x times x. So those two have to stay there. Now remember, here comes the guessing part. We need factors of negative 35 that needs to go in here, and I want them, after I multiply the binomials, I want the product to have -9 in the middle. So what are factors of -35? So 7 and 5 might work, and since it's a negative, we know that I need to have a minus and a plus. So let's try -7 and +5. That will multiply to be -35. Check the inside product, -7x. Outside product, 10x. Did that work? Nope, that's going to be +3. So those are not the correct numbers to put in the factors. Let's try a different combination. Maybe we'll just switch the order. Now let's put, I believe it was -7 over here and maybe +5 there. I have a 5x and then -14x. Okay, so then if I combine those, that will work out, -9x. So that's the factorization I want. So now that I have the factors, which were 2x plus 5 and x minus 7, I take those factors, and since I'm multiplying together to get a product that equals 0, I know that by the zero product property, that's from lesson 1, you need to remember that. Zero product property. What does product come out of? Product means I'm multiplying something and it multiplies to be 0. So zero product property states that when I multiply several terms together and I get 0, then one or all of the terms have to be 0. So the first factor I had was 2x plus 5, and that factor itself could be 0. Or the second factor I had was the x minus 7, and that factor could also be 0. So let's solve for the possibilities of x. The one on the right side is pretty easy to solve. We're just going to have to add 7. So that means that x equals 7. And if I solve the factor on the left, I would subtract 5 first. Kind of doing the opposite of PEMDAS, which again is the order of operations. Instead of starting with parentheses, I'm going to use addition and subtraction first and get rid of that when I solve. So then I get 2x equals -5, and now I'm going to do the multiplying dividing parts to solve for x. Divide by 2, and so my answer, and I can just leave it as a fraction. There's no need to use the calculator and get the approximation, although it would be -2.5. So x equals 7 and x equals -5 halves would be our solutions. You can see the difference between what our factors were and what our solutions were. Right? The factors are what we set equal to 0 to get our solutions. Solutions, again, are the values of x that make the equation true. So solutions should be values or x equals. Now I know that some of you might be in a different class or maybe have another teacher that tells you need to write the ordered pair, which is fine. You could plug in 7 to the equation, but you would get the coordinate when you put 7 in. I should get 0 out for y. When I put -5 halves in, I should get 0 out for y as well, because again, these are the values that make the left side equal to the right side. And if it makes the left side equal to the right side, the left side would have to be 0. But in my class, I want you to write x equals for the solutions. Now over on this one, solve the polynomial. 3x squared plus 34x equals -11. Now I don't want to leave the side with a number on it. I want to use the zero product property, so that means that one of your sides has to be equal to 0. So my first step to solving this polynomial by factoring would be to add 11 to both sides. And so the equation I would solve would be 3x squared plus 34x plus 11 equals 0. So that's my equation. 3x squared plus 34x plus 11 equals 0. And now I want to solve by factoring. First, go through the algorithm. Is there a greatest common factor for these terms? 3, 34, 11, nope. X squared, x, no x's. So there's no greatest common factor. Special case, do I have a perfect square in the first term or the last term? Nope, 3 and 11 are not perfect squares, so no special case. So then we're down to just good old factoring. So now we have to figure it out. Again, we're lucky because the first situation, the first times the first, only has one possibility. 3x squared is prime, so I only have 3x and x is the only possibility. And lucky us too, the third term, the linear term, or I'm sorry, the constant term, 34x is the linear term, is 11. So that means I can only have 11 and 1 as my possible terms here. So I just try things out. And now they're both positive, so I know that the signs inside the factors have to also both be positive. Let's try putting 11 first. I get 11x, and I get 3x. That adds to be 14x. and I need 34 in the middle. So that can't be the proper terms in there. So we're going to rearrange these factors. Let's put 11 on the other side. I know that this is our only option because there's no other way to get positive 11 and add to be positive 34, so this better work. All right, so I got 1x, and then 3 times 11, sure enough, is 33x. Thank goodness I get 34x in the middle. This thing is factorable. So my factors then were 3x plus 1 and x plus 11. And again, we're going to use the zero product property, the fact that these two factors, when multiplied together, equal 0, to solve this equation for x. Because the zero product property states that one of these two factors has to be 0, I just set the first factor, 3x plus 1, equal to 0. I solve, I get x equals negative 1/3. I'm kind of waving over some of the algebra here because I don't want to take up too much time in this video. But you should go through and double check how I got that by solving for x using the opposite of PEMDAS. Now the other factor is x plus 11. I set that equal to 0, and that's much easier to solve. X equals negative 11. So it's important to note now that I got both solutions to the equation for x. That is, I found both of the values of x that would make this equation true. So the point it's worth noting here is that these are just values of x, so you should have x equals. So x equals negative 1/3 or x equals negative 11. It's important that you write the or there. It can't both be negative 1/3 and 11 at the same time. It has to be one or the other. The number or variable x can only take on one value at a time. All right, let's go through and do another one of these quickly. Again, I want to take advantage of the zero product property, so I want one of these sides to be equal to 0. So I'm going to move this 10x over to the other side by subtracting, using the inverse operation of positive 10x. Inverse of adding would be subtracting. So minus 10x plus 3 equals 0. So that's my equation I need to solve. So again, I start out with an equation that's set equal to 0 in order to solve by factoring, because I want to take advantage of that zero product property. So I look for a greatest common factor first. Nothing. There's no greatest common factor. You should be able to verify that. It's not a special case because there's no perfect squares. So no special case. So then I go straight to just factoring by guess and check. I know, again, we're lucky with all these prime numbers. 7x times x is my only choice for positive 7x squared. And I get positive 3 with a negative 10. So that means that these signs have to both be negative because they need to multiply to be positive, add to be negative. Another good nice thing is that this has to be 3 and 1. There's no other way. Let's check to make sure I picked it right. I think I got it right the first time. Negative 3, negative 7, that makes negative 10, x. And so we're good to go with that particular factorization. So my factors, again, 7x minus 3, x minus 1. Remember, I broke that original equation into two binomial factors, and that's helpful because they're easier to solve for x using the zero product property. So 7x minus 3 equals 0, x equals 3 over 7. You can just leave it as a fraction. There's no need to use a calculator and find the decimal approximation. The other one, x minus 1 equals 0, which is clear that x was going to equal 1. I almost just jumped to that one. You could see x equals 1. So my solutions, the values of x that make this equation true, is x is 3, 7, or x is 1. It can't be both at the same time. And finally, let's practice a little bit more what I did at the start of this video on writing the factors that would yield these solutions. And again, the trick is just to add or subtract and get the factors back. Right? So we're getting those factors that would have been set equal to 0. And then once I get those factors that would have been set equal to 0, I just multiply them back together to find out what that equation would have been to start with. So I would have gotten x squared, and minus 6 plus 3 would be negative 3x. Minus 18 would have been my original equation for those factors. Do the same thing on the other side. Now this one's tricky. It's just a fraction though, so don't be afraid. Minus 3/4. So I have x minus 3 over 4 equals 0. If you don't like fractions, just multiply by the denominator of the fraction on both sides. You'll see that it doesn't change the right side. The left side would have been 4x minus 3, because I would have distributed the 4 to both of those terms, equals 0. And that's one of the factors. And the other one would have been x plus 2, it looks like, equals 0. And I can multiply those together to get what the factors would have been to start with, or the quadratic equation would have been to start with. So that would have been 4x squared, and I have plus 8 minus 3, it would be positive 5x minus 6 equals 0. All right, make sure to write the summaries and answer the questions or comments you have. and I will see